Hey guys, so this question is pretty straightforward. It says that using the orthonormality of plus ket and minus ket, prove that Si, Sj's commutator is equal to I Levi-Civita ijk h bar sk, and the anticommutator of Si Sj is equal to h bar square by 2 Kronecker delta of ij, where we have been given these expressions of Sx, Sy and Sj. Alright, so let's start with the commutator property of Si, Sj is equal to I Levi-Civita ijk h bar sk. So the orthonormality condition is just that orthonormality condition is just that the inner product of plus with plus is equal to the inner product of minus with minus, which is 1, and the inner product of plus with minus, which is equal to the inner product of minus with plus, is 0. So we'll prove for these identities. Let's start with Sx, Sy is equal to I h bar Sz. We'll just prove these directly using the orthonormality property. So Sx is h bar by 2 plus ket of plus bra of minus plus ket of minus bra of plus, and Sy is I h bar by 2 minus of ket of plus bra of minus plus ket of minus bra of plus. So let's calculate Sx, Sy first. So Sx, Sy would be h bar square by 4 times I plus minus plus minus plus times minus plus minus plus minus plus. There's just pluses and minus gets here, so we get I h bar square by 4. So multiplying this with this would have an product with this, which would become 0. Similarly with this it will become plus and plus. Then this with this would be minus of minus and minus, and the last one would be this with this, so it would be 0. So now we'll do it similarly from Sx. So again we have h bar square by 4, which would be just, let's see, we'll have minus of plus minus plus minus plus, my god, I'm saying minus plus so many times, so minus plus, actually plus minus plus minus plus. So you can okay, I'll be quiet during the calculation. You can calculate it on your own. I'll do it for you anyways. So alright, so as you can see, we got, if we can write this like I h bar times h bar by 2 cat of plus bra of plus minus cat of minus bra of plus bra of minus. So this here is just sz, right? So we get that the commutator of sx comma sy is just I h bar sz. You can use the orthonormality condition and similarly prove it for sy comma sz, which would be equal to I h bar sx, and sz comma sx, which would be I h bar sy. If we write it in a condensed form, we can write it like si comma sj is equal to I h bar Levi Civita symbol ijk sk. So I have done it for this. You can check for these two, it does hold. You just have to plug in the orthonormality condition and calculate it. It's very easy, so I hope you can do it. So for the second one, which we have to prove for the anticommutator, it is sx comma sy. You have to prove that it is h bar square by 2. H bar square by 2 Kronecker delta ij. In this case it would be xy, so this would become 0. This would eventually come up to be 0. Let's check if it's 0 or not. So for s comma y, we'll have sx sy plus sy sx, which will be equal to, we'll just add these two values which we found earlier. So we have to add this value and this value. So and you can see that this term will cancel out with this term and this term will cancel out with this term. So yeah, we do get a 0 here. So let's check for sx comma sx1s, for which case that for the case of I is equal to j, that is. So we should be getting h bar square by 2 as the final value. So here we'll get h bar square, actually it would be 2 sx, right? So it would be h bar square by 4 times 2 times plus minus plus and the same thing, plus minus plus minus plus. So let's see what we get. Okay, so this would be 2 over here, and this would be 0, this would be plus, this would be minus, and this would be 0. So we'll have h bar square by 2 times plus cat plus bra plus minus cat minus bra. Alright, so if you look at it properly, this thing here is the identity matrix, because you know that identity matrix can be written as sum over ai, where AIs are the basis cats. If that is not clear, then you can take the plus to be 1 0 and minus to be 0 1, and then you can solve for this expression. You'll find that you'll get the identity matrix, that is 1 0 0 1. So I can just write this expression to be h bar square by 2. So yeah, you can see that if we have the anticommutator si comma sj, then we'll get an expression like h bar square by 2 Kronecker delta ij, where if I is unequal to j, you'll get the value 0, and if I is equal to j, you'll get the value h bar square by 2. That is all with this question. You can check the rest by yourself. It's similar. It's just tedious calculation, that's all. I can trust you on that. So that will be it with this video. See you next time.